If Canon's RF 15 to 35mm f2.8L IS USM's breathing is anything to go by, wide-angle internals focusing zoom lenses can be incredibly interesting when it comes to breathing. Of course, the question then is, will the EF 16 to 35mm f4L IS USM behave just as strangely as its RF 15 to 35 counterpart? Or will it perform more like any other internal focusing zoom that I've looked at? What's up, everybody? I'm Jason, and welcome back to this mini-series looking at breathing on several of Canon's lenses. This time we are looking at the EF 16 to 35mm f4L IS USM lens. Now, if you're new to all of this, you might be wondering, what the heck is breathing and why is this guy saying my lens does it? Well, put simply, breathing is a term that's used to describe the change in angle of view that accompanies focusing. This aberration poses a problem for video shooters where that constant change in composition while focusing can become a significant distraction. Now, fortunately, purpose-built video and cinema lenses are designed to prevent this from happening. Unfortunately, for most of us using hybrid or old DSLR lenses on our mirrorless cameras, well, many of our lenses still suffer from this aberration. Now, with that said, my test protocol for all of this is pretty simple. I have a pair of white targets, just a bit of gaffer tape, stuck to a black photographic background. I have my camera set up so that the targets are positioned near the edge of the frame, and a series of shots are made starting at the minimum focus distance and moving out to infinity using my camera's focus bracketing function. Now, for completeness, these test images are all shot as small JPEGs, though any size JPEG will work. Now, as an aside, there aren't any advantages to using RAW here, so I didn't. That's why none of these are done in RAW. I also didn't turn off distortion correction in the camera. Now, part of the reason for that is because many of us will have it on anyway, and I want this to be somewhat realistic, and part of that is because more lenses these days are forcing us to use it without us having a choice in the matter. Now, the real magic for this process, however, happens here on the computer, where I load those JPEGs into some software that I wrote that measures the distance between the centers on each frame, and then ultimately compares those distances to the distance that is in the last image taken, which is going to be at infinity focus. By comparing the infinity position, which tells us the true focal length and therefore the angle of view of the lens, with each of the closer positions, I can then determine how much the angle of view is changing per focus step, and then plot that against the focus distance or focus position. So interestingly, in contrast to what I saw with the RF 15 to 35, the EF 16 to 35 f4 has very similar characteristics in terms of breathing across its whole zoom range, and it's actually pretty good. Starting at 16mm, we see the lens has a total approximate amount of breathing of 4.5%, going from infinity to its minimum focus distance of 2.8 or 0.28 or feet or 0.92 meters. However, with all of these lenses, breathing increases exponentially as the focus distance gets closer to the camera. In my experience, you can still have some breathing in your images or in your footage without it becoming overly distracting, as long as it stays under about 2-ish% all told. Less is obviously better. Now, given that criteria at 16mm, that gives you a working range of approximately 1.5 feet or 0.46 meters to infinity for a total range of 2% change. Zooming out to 20mm, and the story really isn't that different. The total amount of breathing does increase slightly, rendering an angle of view 5.8% wider at the closest focusing distance than compared to infinity. However, the 2% transition remains at around 1.5 feet or 0.5 meters, so pretty much the same. Zooming out again to 24mm, and the situation still hasn't changed much. The maximum amount of breathing is slightly less than at 20mm, coming in at 5.7%, and that 2% threshold distance is at 1.76 feet or 0.54 meters. Now stepping out yet again to 28 millimeters, and if you guessed that things haven't changed again, well, you win that mythical prize. The maximum change in angle of view here is just 5.4% wider at the minimum focusing distance, and the 2% threshold happens at 1.5 feet or 0.45 meters, almost exactly the same as it did at 16 millimeters. Now the final zoom setting under test and the final setting on the lens is 35 millimeters, and lo and behold, it doesn't do anything different from the previous positions either. The total amount of angle of view change is 5.2% wider at the minimum focus distance, and the first 2% of that change between infinity and 1.53 feet or 0.46 meters. So, with all that said, what does this tell us about this lens, or wide-angle lenses for that matter in general? Well, for a wide-angle zoom, it behaves very consistently. Moreover, if you want to keep breathing to a minimum, you can use this for video, and you can, as long as you consistently remember to use it to between basically 1.5 feet and 2 feet and infinity. Though, to be honest, what I found most interesting about these tests is that, unlike the RF 15-35 f2.8L, which in honesty is very similar in terms of overall design, this lens didn't do anything crazy like that lens did. So, with that said, I hope you found this useful, or at least interesting. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. If you'd like to help support this channel, you can help us by liking and sharing this video. You can also support us directly by hitting that thanks button or buying yourself something that you've always wanted from one of our affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.